All right, so one of the last things we're going to do in this section, at least, or in this introduction to polygons, is try to figure out how to find the area of polygons, okay? Now, this is kind of a tricky procedure, so I'm going to give you two examples kind of quick today, and then the assignment is for you to try a couple on your own. Now, key thing here is all these examples we're going to be doing are going to be regular polygons, which means that, again, all the sides and the interior angles are all going to be equal in all these shapes. So just keep that in mind when you're doing these problems, okay? So I need to find the area of this regular pentagon. That's a 5-sided polygon. Its side length is 15 feet, and again, that's all the information they're going to give me. Now, in order to do this, there is really no formula for this. The way we're going to do this is we're going to split this into a bunch of smaller shapes that we do know how to find the area for. And the shape that I'm going to split this into is triangles, okay? So imagine the center of this pentagon. If I were to connect from the center of this shape to the vertices, aka the corners, I would just be making pretty much 5 equal little triangles there, okay? Now, what else could we figure out about these triangles in order, again, for us to get the area of this polygon? Well, in order to find the area of these triangles, because again, that'd be great to know, because if I found the area of one of these triangles, I could just, add it up 5 times, because again, there are 5 equal triangles in there, well, I already know one of the triangles or all the triangles' bases, right? But the thing that I want to find is the height of one of those triangles. And in order to do that, I would need to know a little bit more information about these triangles. So what I'm going to do is I'm going to try to figure out a little bit about the angles of this triangle. And I could do this one of 2 ways. One, I could try to figure out what's known as the central angle of this polygon. That's going to be a pretty quick way of getting this top angle here. Or I could figure out the interior angle of this polygon, because we've learned how to do that, and then kind of split it in half, because again, that interior angle will be split between these two triangles here. Now, I think the easier way would be to actually get the central angle of this. And the reason being is central angles, or all of these 5 angles coming together here in the middle, is just going to be 360 degrees, and I think it's just a quicker way of doing it. So what I'm going to do is I'm going to figure out the central angle. I'm going to do that by taking 360 degrees, because that's, again, all of these central angles added up, and I'm going to divide it by 5 to figure out what just one of those central angles would be. And again, I divide by 5 because there are 5 angles there at the middle. So 360 divided by 5 is going to give me 72 degrees, okay? So if I were to zoom out here, or zoom in on this triangle, I know that the base length is 15. I know that the central angle here is going to be 72 degrees. And I'm really interested in finding out the height of this triangle. Well, again, I'm not sure how this perfectly helps me, but I do know that the height of this triangle really kind of just splits this triangle in 2, and it splits it into 2 right triangles, okay? Because I can assume that this base, again, and this height are perpendicular to each other. So if I were to split this triangle into 2, it's going to split not only my base in half, but it'll also split my central angle in half. So I'm just going to focus in on one of these right triangles here. And 15 split into 2 is going to give me 7.5. And 72 split in half is going to give me 36 degrees up here. And what I really, really want to know is this height. Now, if I can figure out this height, that would help me then get the area of this triangle, and then again, make it so I could find the area of all the triangles, and therefore the area of the polygon. So, in order to do that, think back to trig for a second, aka your SOHCAHTOAs. I think we have enough information to figure out what the height is. And if you guessed tangent to figure that out, you would be correct. So this would be my angle. This would be the opposite side. This would be the adjacent side. And I could set up a tangent problem to help me figure out what that height length is. So let's go ahead and do that. So tangent of 36 equals opposite 7.5 over adjacent, aka the height. And I could just go ahead and go into my calculator, type in tangent of 36. I get it to be 0.73 over 1 equals 7.5 over h. I can cross multiply. So 0.73 times h equals 7.5. And then last but not least, I can divide both sides by 0.73. And h is going to equal whatever that is, which is going to be about roughly 10.3. So that's going to be the height of one of these triangles. So if I backtrack a little bit, figured out what the height was by figuring out tangent. This height, again, is 10.3. So now I have enough information to actually find the area of one of the triangles, okay? And the area of a triangle, again, is 1/2 the base times the height. So I have both pieces of information now. 1/2 the base, in this case, 15. Again, because one of these triangles from this original triangle is, again, 15. And I'm going to multiply that times the height, which is 10.3. And that should give me the area of one triangle. So I got 0.5 or 1/2 times 15 times 10.3. And my calculator is popping out approximately 77.25. And that would be the area of just one of those triangles, okay? Now, again, that's just one of those triangles from my shape. I have 5 of those triangles. So, if you guessed it, what I'm going to do to get the entire area of this polygon is I'm going to take the area of one triangle and I'm going to multiply that by 5 because there are 5 of those triangles. So, my final answer, so the area of the polygon, would be pretty much taking the area of one triangle, which would be 77.25, and multiplying it by 5, because there are 5 of them. So I'm going to multiply that times 5, and that is going to give me my final answer, which is 386.25. In this case, it would be feet squared, because my original measurement was in feet. But that would be how I would get the area of that polygon. Again, in summary, I took the polygon, split it up into triangles, and then I took that triangle, once I figured out a little bit more information about its central angle, into a right triangle by splitting it in half. Used some of the stuff I knew about SOHCAHTOA to figure out the height, and then the rest was pretty much history. I was able to find the area of one of the triangles, and then from there multiplied it by how many triangles in the polygon, and that is again how I got my answer. Now, very, very quickly, because I know you don't want to hear me talking all day, I'm going to do one other example, but this time instead of me giving you a side length of this regular, in this case octagon, I'm going to give you what's known as the radius. Now, a radius of a polygon is the measurement from the center of the polygon to one of its corners. So if I give you a side length, that's one of these guys. If I give you a radius, it's from the center to the corner. Okay, so there's a key word for you, the radius of a polygon. But you probably already have heard the term radius before. Anyway, so let's get started. I'm going to split this into triangles now. Again, 8 triangles in this shape. You don't have to really draw this every single time, but if it helps you, go for it. I'm going to think about just one of these triangles. I know that this length is 2. I also would know that because all these triangles are the same, this length would be 2 as well. Now, what's nice about this situation is the type of triangle that this is, well, this is just an isosceles triangle. And if I can figure out what the central angle is, I can actually get all this other information relatively quickly. So what I'm going to do is I'm going to get the central angle again. I'm going to do that same way as last time, taking 360 degrees, which is all of these center angles added up, and dividing it by, in this case, 8, because there are 8 equal angles meeting up there in an octagon. So 360 divided by 8 is going to be 45. And then from there, I can kind of split this triangle again in 2, like I did last time. And let's see here what I have. It'd be 2 right here. And and 45 would be split in half. So that would be 22.5. And from there, what I would do is I would probably want to find two sides here, because if I'm going to try to get the area of this triangle, I'm going to want to get the base length. I also would want to get the height as well, because again, I'm trying to get the area here. So I'm going to do that. So I'm going to need this length. I'm also going to need this length. This is going to kind of require me to do two problems here. I'm going to have to figure out x, and then to do that, again, I can use SOHCAHTOA. In this case, I'm probably going to want to use sine. And then to figure out y, I can use cosine, because x would be the opposite in the shape of that angle. This would be the hypotenuse, and then this would be the adjacent. So I'm going to start by finding x. So I'm going to do that by using sine of 22.5 equals opposite over hypotenuse, which is 2. And I'm going to go ahead and cross multiply and everything. So 1 times x, and then 2 times sine of 22.5. So that would be the answer for my x. So I'm going to just real quick do that. So 2 times the sine of 22.5 is going to be roughly 0.76. And then I'm going to also get the answer to my y. So I'm going to do this time cosine of 22.5 equals adjacent over hypotenuse, so y over 2. And I'm going to, again, cross multiply, so 1 times y, and then 2 times cosine of 22.5. And I'm going to get 2 times cosine of 22.5 is 1.85 if I rounded. And there would be my two missing lengths. So I got my base length here is 0.76 and my height here is 1.85. So if I were to put this back into this, my height of this triangle is, again, that 1.85. And my base, or at least one of the parts of the base, is going to be 0.76. And this other one would be 0.76. If I want the entirety of that base, I would probably add those two lengths together. And I would get 1.52. So that would be the length of that entire base. Okay? So let's find the area of that triangle, and therefore we can get the area of the polygon. So get the area of the triangle. Triangle area. So what we're going to do is we're going to do, again, 1/2. The base in this case is 1.52. The total base times the height, 1.85. And I'm going to get the area by going 0.5 times 1.52 times 1.85. And I'm going to get an area of 1.41 if I rounded. Okay, so that's just the area of one of the triangles. But as you, again, probably assumed, there are 8 of them. So to get the area of the polygon, I am going to have to take the area of one of the triangles, and in this case, multiply it by 8, because there are 8 triangles there. Because again, 8 sides to a polygon, or 8 sides to a octagon. So 1.41 times 8. And that is going to give my final answer of 11.28. And in this case, the again is in terms of feet, so I'm going to write feet squared for my final answer. Okay, so hopefully these 2 examples help you with the assignment today. If you need a little additional help, you can drop in office hours, which again are every day from 1 to 2. Hope you have a great day. See you later.